back to the UK. I come from Heriot University in Edinburgh, so again, not Cambridge, but we're back again to the UK. I'll present the results of a review that basically centers on how digital twin technology can be leveraged, particularly in terms of improving design from an occupant point of view in buildings. Again, I really like this quote to start with. Some of you might have come across, but it kind of signifies very clearly how buildings and occupants are almost like a symbiotic relation, so how we kind of design and shape our buildings, but also how once we use them and once we inhabit them, how they affect us as well, from how do we feel inside to how do we actually experience things like thermal comfort or similar things. However, when you look at historical research, when it comes to environmental research, human geography, and so on, there is a very big challenge when it comes to occupant data, particularly in trying to understand this phenomenon of how buildings actually affect us. And in that case, some of the issues that you can see is, first of all, the difficulty of attaining really longitudinal data that is kind of regularly collected and updated. Usually, the traditional ways have been experience surveys, which tend to be more like one-off processes. Another one is actually establishing connections, so establishing how different features in the building might affect us. I'll talk a bit later about some theories, but again, those theories have been developed over experimental research over 10, 20 years on multiple buildings. So that has always been a big challenge to establish those relationships. And the final one, again, not only how the building affects us, but how our behaviors affect the building performance has always been a traditional problem when it comes to energy modeling. And again, that's kind of signified, for example, by a very common or frequent phenomena, which is the energy performance gap, which basically is the difference between the simulated or predicted energy at the design stage and the actual energy when the building is in use, which sometimes is pinpointed on the occupant in certain cases. Again, in that context, it's quite interesting to see the opportunities that digital twins offer us. In particular, again, one of the principles of digital twins is that kind of dynamic, regular collection of data. So again, new kind of additional sensors that we might be using, and always that kind of allows us to generate more kind of longitudinal data sets almost by kind of principle of what a digital twin is. Similarly, there is much more granularity in the data that we can collect nowadays, particularly in the form of the sensors that are built within buildings, but also there is quite a lot of possibilities when it comes to systems control. We have much more granularity over building services and how they perform in commercial buildings, for instance. Without going a lot more into the background, one of the reasons for this review is that while there is examples of systematic reviews done in digital twin research within buildings, there is nothing that has primarily focused on that aspect of the occupant data and, again, how it's been integrated in recent digital twin applications. So, again, the two main purposes of this review are going to be, first of all, the identification of that different types of occupant data that have been integrated, but also a categorization, very simple categorization of those types of data. And the second one is also identifying major challenges that current kind of integration of occupant data is having when it comes to digital twins, as well as discovering emerging directions for research. So again, the systematic literature review, very simple, 2 steps. The first one is mostly automated, retrieving the data from Scopus, which was the selected database. Again, the search query with the keyword parameters and the booleans is on the paper, which might not be very clear there. But this kind of initial step have a couple of exclusion criteria as well, and I'll talk a bit about them later on. But one of them was the inclusion of only peer review journals within the sample papers. And the other one was the inclusion of papers in English, so it should be published in English. The first query resulted on 40 articles, so the second step was a manual kind of retrieval among those 40 articles, mostly through looking up the abstracts, but also, in case of the abstract was not entirely clear, looking at the paper methodology. And again, the two main exclusion criteria there were Many of the papers, while they mention digital twins, they're not necessarily related to a digital twin application. Sometimes there were cases of simulation that had no really real data integrated into the digital model. And in other cases, the focus of the paper was a digital twin, but it was a digital twin of neighborhoods, for example, or other infrastructure systems. So not necessarily a building in itself. So the final sample is 20 papers. Again, the full bibliometric details of those papers are on a big table on the paper. So I will jump directly into the findings. And again, the first kind of finding, just looking at kind of the use cases that were featured within the papers or the purpose for which these digital twin applications were being developed. And by far, there were two kind of primary purposes identified within the 20 digital twins. This one being primarily energy optimization. So again, always the digital twin data collected through it and the controls and operations of the building, trying to achieve an optimization of the energy that we were consuming in those cases. Again, there are plenty of examples, but that's one of them. As well as the early failure detection that was also quite common in a number of cases, so mostly linked to preventive or predictive maintenance as well, so how we can save cost by acting early within kind of with our building services and systems in terms of maintenance and operation. There were some additional kind of more niche purposes that appear on the sample. One example is a paper that was focused on fire safety and evacuation of occupants, and another one that looked at other kind of different possibilities to enhance other functions common in facilities management, primarily planning for cleaning requirements on buildings. Again, when it comes to the second point, again, classifying the occupant data, I use a very simple framework which will have two axes to it. The first one will be mostly about the nature of the data. So on one end, it's data that it could be considered mostly objective data. So there is not necessarily any user input or any subjective kind of experiential aspects to it. And on the other end, there is more like, again, that experiential data that might try to capture how the user feels or experiences the building. And similarly, in an additional kind of axis, I categorize as well the requirements in terms of the occupant involvement when collecting that particular data. And on one end, there are the more passive or systems that will require a very low occupant involvement, while at the other end, it will be systems that will require either quite a lot of involvement, directly the user inputting their data, or otherwise, and we'll see there as well if consent is directly required for capturing some of that data. By far, the most common type, again, on the objective kind of passive quadrant of the data set, it was the occupancy sensors, more commonly used ones, CO2 kind of volume sensors, as well as passive infrared. Mostly sensors that will give us data on occupancy rates on different rooms and spaces across the building. Again, quite an unintrusive and relatively inexpensive source of data. Another one that is emerging, and there is a couple of examples in the sample papers, is more like using image-based sensing from the operation of buildings. So again, CCTV footage, for example. The difficulty here is it usually requires much more complex approaches to analyze or process this data. Again, in this case, the paper covered mostly computer vision and how that could be used for determining needs for cleaning and maintenance in a building. The second quadrant, again, quite a lot of emerging types of data as well. On one hand, you have like indoor tracking of users within buildings, usually through strength of signal kind of approaches. In that case, it was the most common one, Bluetooth low energy, relatively inexpensive to build the infrastructure of Bluetooth beacons. And everyone has nowadays a transmitter that could kind of connect or be used to geolocate you within the building, either in your smartphone or in some cases, smartwatches as well. And the other one, which is quite interesting, is the use of wearables. There is 2 examples on the identified papers, which looked at the integration of this physiological data, heart rate, skin temperature, even detecting movement from users. Obviously, these ones don't necessarily require a high kind of user involvement in providing the data because they are collected relatively automatically. However, they require direct consent, so that's why they go much higher than the passive sensors that I talked about before. The final one is the kind of more subjective types of data, which the 2 examples that were also identified were the traditional use of occupant surveys, which, again, for those that might have worked with indoor environment quality, you might be familiar with some of these, but these are already standardized instruments that we can use to collect data from or around the thermal comfort experience of users. So again, those were featured in one of the papers. However, a nightmare to integrate in the digital twin. It was probably done manually, even though it's not very clear in the paper, but also the potential to lead towards survey fatigue from the users, particularly when those are done very regularly. And the other alternative is experience sampling method, which is basically uses some of these established constructs, thermal comfort, if that could be the focus, but measures a few of them. And in general, it kind of collects the data on point, usually, again, linked to the wearable devices where the smartwatch might send a prompt that requires the user to input how they're feeling at that particular moment, as well as other data that you might want to collect through it. Again, that was also featured in 2 articles. And again, it's much more rich in the sense that you generally have the data on the moment, so it reflects the actual experience, but also you get the data positioned within the building usually. On the other quadrant, I couldn't really identify many sources, so I left it a bit of empty, so I wouldn't say that there is a very clear type of subjective data that would have low involvement. But one example that was very hard to categorize is the use of data from facilities management systems. In that case, the paper integrated timetabling in their kind of model. Again, when it comes to looking at the emerging issues, 3 primary or interesting ones that I would like to discuss. The first one looks a lot at occupant interaction. Traditionally, when designing digital twins, the focus tends to be that the interface will be designed for the facilities manager or the operation manager on the building. So again, we always design it basically on how we can support their function. However, again, an interesting paper opened up the possibility of having a much more interactive and open interface that will also be opened up to the occupants directly. Again, this is quite an interesting paper because the development of the interface involved quite a lot of design prototyping, and some of the issues that were raised here link a lot with the potential challenges going forward, particularly when it comes to the ethics around occupant data. And again, particularly in occupant-centric digital twins, who owns the data, how that data is visualized, how can we avoid identifying users, for example, in an office building, like it was the case here, where you could see the comfort profiles of other kind of colleagues in the building. And the other one is also quite interesting. Obviously, once you start having multiple data streams, you need to kind of integrate these ones. So again, the other one was looking at methods to integrate this one, and very commonly, knowledge graphs, and I think that's my cue. Can I just... So again, some directions for research will be looking at how this interaction might impact the building performance and the experience of users. So again, this is also quoting a very established theory, which is the theory of adaptive comfort. But again, that's a very interesting question that could be explored going forward. But also again, digital twins are usually for fine-tuning and optimization of energy performance of the building. However, I would argue that some of these data sets that are being generated through digital twins have a lot of potential for other fields, in particular evidence-based design, where, as I was saying before, very hard to establish direct connections. However, once you have multiple data streams and quite large data sets, you can probably explore other non-deterministic methods to come up with conclusions. So again, that could benefit a lot these kind of fields of work. Again, limitations of DSLR, I can talk a bit more on the questions if necessary, but yeah. Basically, final conclusion, 1 minute? Yeah. Sorry about that. But yeah, it's like most of the examples tend to be more like an occupancy-centric kind of digital twin, even though sometimes the claim is that they are occupant-centric. They rely a lot on sensors that only give you information on occupancy. However, a true occupant-centric digital twin will require multiple data streams, including potentially some subjective data, some of that data that is objective, but tracks as well the behaviors of the user on the building. That's the only way to generate really rich insights on preferences and behaviors. And again, some of the challenges that I just discussed previously in there regarding methods, ethics, and also how scalable some of these solutions are. Yeah. So yeah, sorry, because it's also the last one before, but yeah. Okay.